Before we get into this next part, make sure you're comfortable simplifying factorial notation. The ratio comparison test for series. This is the most important test that we're going to have. This is going to be our go-to test. So if the series an is a series of positive terms, then the limit as n goes to infinity of an plus 1 over an equals L. Okay, so first of all, make note that these are consecutive terms. We're taking a ratio of consecutive terms. Okay, so an plus 1 and an are consecutive terms of the sequence. Our conclusion then is going to be, once we take a limit, if the limit is less than 1, just like the nth root test, if the limit is less than 1, it converges. Okay, so that is a good series. If the limit is bigger than 1, it diverges. Okay, we don't want the limits to be bigger than 1, just like the last one, and our test is inconclusive if the limit is equal to 1. Okay, so let's take a look at how this is going to work. So we're going to take a look at the sequence, and I'm going to do an plus 1 in the numerator. So I'm going to set it up like this. The limit as n approaches infinity of an plus 1. So an plus 1 is going to look like this. Our an plus 1 is going to be n plus 1 over 2 to the power n plus 1. That's going to be my numerator. And in the denominator, we're going to use an. So it's just going to be what I see there, n over 2 to the power n. And then I'm going to evaluate this limit. Now, before I evaluate this limit, lots of things will simplify. Okay, so I'm going to just rewrite this limit in simplified form, and I'm going to kind of split this up into two parts. There is this an part, sorry, the 2n part, and then there's the other part, which I'm going to maybe highlight in, let's do that in blue. Okay, so it's going to look like this. There's going to be an n part of this limit, so n plus 1 n plus 1 over n. It's going to be that part of the limit. And then there's going to be the 2n part of this limit. I'm going to do this in green. The 2n plus 1 ends up in the denominator. And the 2 to the power n ends up in the numerator. And we can evaluate these limits separately. And we can kind of see that the limit as n goes to infinity of n plus 1 over n is going to be equal to 1. We should simplify the green expression first before we evaluate it. Limit as n approaches infinity of, I'm just going to keep it the same for now, n plus 1 over n. Okay, at infinity, that's going to be equal to 1. And the 2n over 2n plus 1 means we have an extra 2 in the denominator. It's going to look like that. So evaluating this limit then, it's going to be equal to 1 times, so that part's going to be equal to 1 times 1/2. So our limit is equal to 1/2. Okay, now if we go back up to our results here, it converges if the limit is less than 1. Well, the limit is less than 1. That is less than 1. Therefore, it must converge. So L is less than 1. Therefore, the series is convergent.